Hi, STEM 1 students. I wanted to first apologize for the quality of my voice. I'm fighting a bit of a cold, so bear with me on this today. What we're going to look at today is just one little topic that really you're going to see on your final, but I think there's only one or two questions. I didn't really want to put a whole unit together for such a small topic, but a lot of times in the business world, we deal with things that, like if people have to raise at least a certain amount of money, or if you have to spend no more than a certain amount of money, you get into these inequalities. And so usually what it means is like there's two variables, one that's an independent variable, which is your x, and your dependent variable, which is a y. And so this relationship might exist where we might have to have less than or more than a particular amount of something. And so the way it works is when we graph this, it's not only a line, it's a region of the graph where any point in that shaded region actually makes the inequality true. And so we'll talk about what that means. I want to first show you the logistics, and then we'll talk about like what it actually means after you graph it. So kind of what you see down here is it's always going to be y less than or equal to, and then some amount here, or y greater than or equal to some amount on the other side. But when it's less than some amount, if it looks more like an L, or if the opening is facing the rest of the function, you're going to shade the lower part of the graph, or if you want to say below the line, that would be what we're going to do when we see the less than inequality. All right, and if we see a greater than, we're going to shade above the line. So, for example, you might have a line that runs like this. Basically, if you start at the top of the picture, you're just going to shade from the top down until you hit that line. Okay? And then on the other one, like this one, the less than, wherever your line is at, you would start at the bottom of the picture, down near the bottom, and shade towards that line, and it would be everything below that line. So it doesn't really matter if it's lines or colored. You just want to indicate that it's shaded somehow, some way. So the line options. Sometimes we're going to have solid lines. Sometimes we're going to have dashed lines. And again, we'll talk about what that means. But if there's no greater than or equal to, or I'm sorry, if there's no equal to symbol, like these ones here don't have a line underneath it, that means that the line is going to be a dashed. And it also means that it doesn't include or does not include the points that are on the line. Again, we'll talk about what that means when we do an example. If it has an equal sign underneath it, or part of the equal sign, that means that y is less than or equal to, or y is greater than or equal to some function. And the line will be solid, which means it does include all of the points that exist on the line. Okay, so let's do a few examples. It sounds more complicated than what it really is. What I want you to do is, before you actually graph this, I want you just to go through and indicate for each question whether it's going to be a solid line or whether it's going to be a dashed line based upon the symbol here. So since there's no equal sign down below it, this is going to be a dashed line. So I'm just going to draw in a dashed line. Okay. Same thing on number 2. There's no equal sign underneath it, so this is going to be dashed. And then on number 3, since it has an equal sign, this is going to be a solid line. All right, and so now we're going to treat it as if we were graphing, for instance, on number 1. We're going to pretend it is an equal sign while we graph it. And this should just be a normal slope-intercept form. The y-intercept is at 1. So I'm going to go to the y-axis at 1. And then I'm going to rise 2, and if there's no denominator on my slope, I'm going to add a 1. So rise 2, run 1, rise 2, run 1, rise 2, run 1. And then before you draw that line in, you want to actually create a dashed line, since that's what we said here. Okay, so this graph will be very similar to what we've been doing. It's just instead of a solid line, we're going to use a dashed line. And this is the less than symbol. So less than means smaller than. So that means all of the points, if I start at the bottom of the graph, all of the points below that line, sorry, apparently my dog is very tired today. Everything here that would be underneath this line would be shaded. All right, actually, I'm going to use a highlighter because it's going to look a lot better. That looks kind of sloppy. So let me do that. So all of this region down here would be shaded. So what does that mean? Well, it's really simple. That just means any point I could pick. I'm just going to pick 1, 2, 3, 4. Pick this point right here, 4, 1. Any of the points in this yellow region, when I plug them in up here, should work in the inequality. And what I mean by that is the left side should be less than the right side. So let's just try it. My y value was 1. My x value from this point was 4. And if we substitute in the x and y values and evaluate this side, 2 times 4 is 8, plus 1 is 9. Well, 1 is definitely less than 9. Yes, that's true. So anything underneath this line, when we evaluate it, would give us a true inequality. Okay? You couldn't pick like this point here, 1, 0, or I'm sorry, 0, 1. 0, 1 wouldn't work. And I'll show you why, so I'll cross this out in just a minute. 0, 1 wouldn't work because it's part of the dashed line. You can only use points on the line if they're a solid line. So here, if I put 0 in for x, and then I plug 1 in for y, that would mean that 1 is less than 1, and that's not a true statement. So anything on the line couldn't be a solution. That's why we use dashed lines here. Only the points from the shaded region, not including the line. All right. So next one, we're going to use a dashed line. So it's going to be a y-intercept of -2. And I'm going to rise 1, run 3. Rise 1, run 3. And then I'm just going to repeat my trend, go in the other direction. And we said it's going to be a dashed line. And since this is greater than, we're going to start shading from above until we hit that line. So greater than means start above the line and shade this region right here. All right. Any point in this shaded region, when you plug it in, would give you a y value that is greater than whatever you get when you evaluate the right side. Now, number 3 was going to use a solid line, and that's because it has this symbol right here. Okay, so we're going to start at 1, and I've got a negative slope, so I'm going to go down 3, run 4, down 3, run 4, and this one is a solid line, so we're going to draw in a solid line, and again, since it's greater than, we're going to start shading from above the line and color in this whole region above the line. So greater than starts from the top. Number 1, less than starts from below. And it's only a solid line if it has the equal to symbol below it. That's the only time it's solid. Otherwise, it will be dashed. What I'd like you to do is try the next